For a long time, modern design followed one rule: replace, don't repair. Products were sealed, components hidden, and repairs discouraged. When something failed, the solution was simple: buy a new one. That philosophy is starting to break. Across industries, engineers are intentionally designing machines to be repaired, not replaced. This isn't nostalgia or sustainability marketing. It's a response to real-world pressure. Replacement is fast until it isn't. Supply chains break, costs rise, downtime becomes expensive. When replacement isn't guaranteed, repair becomes a strategic advantage. Machines built for repair follow different priorities. Parts are modular, fasteners are standardized, components are accessible without proprietary tools. Failure points are isolated instead of buried. That's not accidental, it's deliberate engineering. A repairable machine assumes something will go wrong. Instead of hiding that reality, it prepares for it. When a component fails, the rest of the system keeps its integrity. This approach shows up in unexpected places. Industrial equipment is returning to open architectures. Vehicles are designed so common, wear parts can be swapped in the field. Tools are built with replaceable internals instead of sealed housings. Why now? Because complexity has a cost. Highly integrated systems are efficient but fragile. When one embedded component fails, the entire machine can become useless. Repairable systems trade a little efficiency for a lot of resilience. There's also a human advantage. Repairable machines are understandable. Technicians don't need black box diagnostics to identify a problem. The failure is visible. The fix is mechanical. That shortens downtime and builds trust. Trust matters when machines are expected to last. In many cases, repairability extends a product's life by years or decades. That changes economics. Instead of recurring purchases, value shifts toward durability and serviceability. This doesn't mean every product should be repairable forever. Some systems still benefit from sealed design, but the assumption that replacement is always cheaper is no longer true. Repair is a form of control. When users can fix what they own, they regain agency. When machines are designed for repair, they respect time, resources, and reality. The return of repairable machines isn't anti-technology, it's anti-waste, anti-fragility, pro-function. Progress isn't just about making new things, it's about keeping good things working. And in a world where downtime costs more than hardware, the smartest machines are the ones that expect to be fixed. The future won't belong to the machines that look the newest, it will belong to the ones that can be brought back to life.